Section 9. Solving by graphing. There are plenty of equations that we can't solve by factoring or by using other algebra techniques, so we need to look at how we can solve these using the graphing calculator. For example, x to the fourth minus 2x minus 1 equals 0. There's nothing obvious that I can factor over here. I might be able to use the rational root theorem that you saw last year in pre-calc, but let's see another method for dealing with this. Solving by graphing. What we need to do is we need to graph the function y equals x to the fourth minus 2x minus 1, and then just find the x-coordinates of the x-intercepts of the roots. To do this, type your function into the y equals spot. Y sub 1 equals x to the fourth minus 2x minus 1. Set your viewing window, and I think a good place to start would be something like negative 10, 10, 1, negative 10, 10, 1. We can change the window if we need to. We'll deal with that when that comes up. I'm going to push graph, and I'm going to take a look at what this looks like. I'm looking for the x-coordinates of the x-intercepts, and I see 1 over there and 1 over there. All I need to do now is find them. Go to second, calculate. Second, push the trace button. Another name for x-intercepts is 0. I want to find the zeros of this function, so go down to number 2. And the way we're going to do this is we're going to create a little region right around the x-intercept that I want to find. It's first asking for a left bound. Well, I'm pretty close to the x-intercept right now. I'm going to move a little bit to the left of that point to create my left bound. Notice that a triangle has shown up. It now asks for a right bound. I need to move somewhere a little bit to the right of my x-intercept. X-intercept's about here, so a little to the right would be maybe something like this. I'm going to push enter. Another triangle has shown up. Before we move on, make sure that your x-intercept is between those two triangles. If it's not, the graphing calculator won't work. It now asks for a guess. We could just leave the cursor where it is and push enter, or we could move the cursor pretty close to the place where it crosses the x-axis. I'll say something like this is about my guess. I'm going to push enter, and my first x-intercept is negative 0.47462, comma 0. The AP exam will expect you to give answers rounded to 3 decimal places or more, so that's what I'm going to do here, and I'm going to say x is about negative 0.475. I now need to repeat this process for the next x-intercept. Second calc, I want to find the 0 over here. Well, I need to start by moving to the left of that x-intercept, and left in this case would be below the x-axis, so move a little to the left and push enter. Move a little to the right of the x-intercept, in this case above the x-axis, and push enter. And our second value is about 1.395. If you wanted to check these, you could take these, you could plug it into the function, raise it to the fourth, minus 2 times that number, minus 1, and you get something pretty close to 0. One more. Let's take a look at 3 sine squared x minus 1 equals x to the third. There are 2 ways we can do this. First, we could make this equal 0 by subtracting x to the third from both sides and then doing the same thing we just did. But another way we could do this is by using a system of equations. We can graph y equals 3 sine squared x minus 1 and y equals x to the third and find the x-coordinates of the points where they intersect. That's what I'm going to do here. Before moving on, I need to make sure I'm in radian mode. My calculator is. I'm going to clear out what was in there. To type in 3 sine squared x. Well, remember that sine squared x is really just saying the sine of x squared. So I'm going to type this in as 3 sine x squared minus 1. Under y2, I'm going to type in x to the third. I want my viewing window to be that same negative 10, 10, 1, negative 10, 10, 1 thing. I'm going to push graph. And I get something like this. Now, I can't see very well what exactly is going on over there, so I do want to zoom in. Rather than using the zoom button, I think it's a lot easier to just change the window manually. I feel like I have a little bit more control over what's going on when I do it like that. I'm going to make my window maybe negative 2 to positive 2, and then negative 2 to positive 2 for the y values as well. Let's see if that works. Not bad over here. It's still a little bit tricky to see what's going on here, but it does look like it's crossing in two places. Let me just start the process and hopefully things will work out. To find the points of intersection, go to Second Calculate, Intersect. The way this works is we first have to select the first function I'm dealing with. I'm on the sine function right now, so I'll push Enter. Then select the second function. In this case, it'll be the cubic function. And then, for a guess, move close to where they cross. I'm going to move close to this point over here to find my leftmost point of intersection. I'm going to push Enter. And I'm going to get x is about negative 0.554. I'm then going to repeat that process over here, and then again over there. Second calc, find the point of intersection. Well, my first curve is still the sine, the second curve is still the cubic one. I'm going to move my guess to about over here. I'm going to push Enter, and it found another point of intersection at x is about 0.772. I'm going to do this one more time with my guess really close to a point about there. Again, if you don't really like this so much, you could change the viewing window again so it's really focusing in a little bit better on that region over there. I've got my cubic curve, my sine curve first, then my cubic curve. My guess is close to that point, and I'm getting about 1.137. These are my three x values that would make that original equation true.